You could use these static resources, the mesh thesaurus or the wordnet or another kind of a thesaurus that you could come up with. You could also try to construct synonyms automagically by analyzing text. Now, the synonyms that you get from these techniques, they're not exactly linguistic synonyms. They're not the kinds of things that you would find in a thesaurus. So that's the downside. The upside is a lot of the time they're more useful than the things that you find in a thesaurus. And you can also do this for languages which don't have readily available thesauri and wordnet-like collections, right? So English is fairly lucky to have wordnet. And again, if you're working in Tagalog, there isn't a wordnet for Tagalog. And you might be hard-pressed to find a thesaurus for Tagalog. But you can always do statistical analysis. So how does it work? The basic idea when you're constructing statistical synonyms, you're not really looking for synonyms. You're looking for words that tend to occur in similar contexts. So you're looking for words that tend to occur in the same documents, on the assumption that documents typically talk about a specific topic. So if one word occurs in a document, another word occurs in a document, and that's repeated over and over and over again, happens over many, many documents, then probably those terms are related in some way. So how do you measure this relatedness? Well, the simplest thing, so here's a bunch of formula that you could use. The simplest one is right there. And all of these basically use three basic building blocks as the component. So N of AB, that's the number of times that I saw two words together in a document or in a window of 50 words, however you define together. N of A is how many times I saw A on its own. N of B is how many times I saw B on its own. So the simplest way to measure relatedness is you take N of AB, how many times I saw them together, and divide by the product of N of A and N of B. So I could use a product. I could also use the sum. Right? This, for some reason, is called the mutual information measure, and this, for some reason, is called the dice coefficient. Right? So which one is better? Is one of them better than another? Are they different? They certainly are different. Now, the first one turns out to have a nice interpretation. So if you look at it, if I divide everything by n, right, that's what I would get. So I divide both the numerator and the denominator by n squared. So then I have n of AB over n. And the way to interpret that is that's just the probability of seeing A and B in a randomly selected piece of text, in a randomly selected document or a window, right? And then at the bottom, I'll have N of A divided by N, which is just the probability of seeing A by itself in a randomly selected piece of text, and P of B. Now, once you look at it that way, you can interpret them, right? So what we have at the top, P of AB, what is that? That is the empirical frequency or empirical chance of how often we actually see A and B together in our data. So this is our observation. And what you have at the bottom is the product of the individual probabilities. And if the words A and B were truly independent as far as probability goes, then the top and the bottom would be the same thing. Right? So the bottom really represents the chance of seeing A and B together accidentally. If they really were unrelated, sometimes accidentally they'll happen in the same context. So you want to measure, what this ratio measures is how much more often you see them together than you would expect by chance. So there's a name for this. It's called the likelihood ratio test, and it's actually used all over statistics in various forms. So that guy has an interpretation. You have others, so the chi-square, that's another statistical test, and EMIM is yet another statistical test. So you have lots of choices in how you measure the relatedness of the words. And a lot of the time, the choice comes down to what performs well in practice.